In a previous video, we looked at the example f of x was equal to x to the fourth, and the particular value of interest was x value equal to 2. And we showed that using the linear approximation formula, which was f of a plus f prime of a times h, okay, that this approximated the function evaluated at a plus h. That was our linear approximation formula. So for example, we were asked for this problem, okay, to find an approximation f of 2.1, and we showed that that was the function evaluated at 2 plus the derivative of the function at 2 multiplied by, and your h value is 0.1. And we showed that the result of that computation right here underlined was 19.2, and the exact answer was 19.4481, and those are kind of in the ballpark of each other. Okay. In this video, I want to show, I would like to show what's going on there geometrically. Okay. And here's a picture of what's going on geometrically. Okay. Run this code here, and we are seeing from this particular problem, from this particular picture, there was a separate problem that you could have been asked to find the tangent line to this function f of x at x is equal to a. Okay, and the particular formula there, the derivative of the function was x to the function was x to the fourth. The derivative is 4x cubed, and when you put in 2 into the derivative, you get 32. So you know that the slope of the tangent line, f prime of 2, is the slope of the tangent line, and the tangent line formula was y was equal to f of a plus f prime of a times x minus a. So we're trying to put in context the approximation that we just came up with, okay, times x minus 2. And according to the sheet over there, the tangent line comes out to be y is equal to 16 plus 32 times x minus 2. Okay, so you can see that picture over here, that at the point of interest 2, we've got a tangent line. And the whole idea of differentiability is that if you were to zoom in and zoom in and zoom in on this function, that the tangent line is a good approximation of the function. You can see that there's no difference between, when I zoomed out a little bit, there is a difference in the function and its tangent, red line there. But if you zoom in a little bit more, there's no difference between the dotted line, which is the function x to the fourth, no difference between it and its tangent line. So what is the meaning here? This function is differentiable. The tangent line is a good approximation, which means that use the tangent line. Okay, and you see here we were asked to find the function evaluated at 2.1. The function evaluated at 2.1, we knew its value was 19.4481. You can see that right here at 2.1, right? Read it up to the black function and read it across to 19.4481, a little bit less than 20. But let's use the red line now. So instead of putting 2.1 into the function, the black curve, instead put 2.1, put 2.1 into the tangent line. Okay, and if you put 2.1 into the tangent line, you get 16 plus 32 times 2.1 minus 2, which is otherwise known as y is equal to 16 plus 32 times 0.1, which should look very familiar to you as f of 2 plus f prime of 2 times h. 0.1 was your h value. And here was the approximation. You got the 19.2 at that point. 19.2 is what you get if you put 2.1 into the tangent line formula. Read it up till you hit the red line and then go across, and you will get 19.2. If you put 2.1 into the function itself and read it up to the black dotted line, you will get 19.4481. But since the tangent line and the function are so close to each other, that's because the function is differentiable. That says that since the function is differentiable, that when you do this approximation, use the tangent line approximation, you're going to get a really close answer to the exact value. Okay? So that is graphically what is going on with these two formulas. You can either use the tangent line formula and plug in the value of interest, in which case when you plug in the value of interest, 2.1 minus 2 will give you the h value, how far they're separated from each other, which was the formula that we were writing up here. So that is, this video hopefully shows the relationship between the tangent line formula here and the linear approximation formula. And basically they are writing on the fact that the function is differentiable, and when the function is differentiable, you are allowed to use this tangent line to give you a good approximation of the function. And that is the end of this video.